81, right? Time is running very fast, and class 9 student you are saying, sir, it's very difficult for us. No time to think anything. What to do? So this 9, 10, 11, 12. This is the time to make your best. How much labor, how much effort you apply, that much benefit you will get in future time. That's why more practice, less rest. No more rest now. Keep on practicing and practicing and practicing. So let me welcome on the stage Sashank Lamsal for his presentation. Give him a big round of applause.
Good afternoon, everyone. Today I am going to discuss exercise of force and motion chapter. Newton's law of gravitation is known as the universal law. Newton's law of gravitation is known as the universal law because it can be used in whole universe.
Understand everything, is it? You can.
The weight of a body decreases with an increase in distance from the Earth's surface. The weight of a body decreases with an increase in distance from the Earth's surface because weight is inversely proportional to the distance of body from the surface of Earth. The weight of stone is less at the top of mountain than at
Keep your leg
its
down, bro.
bottom.
Come.
The weight of
That side.
stone is less at the top of mountain than at its bottom because the gravity is less as it is at more distance from the center of the earth. The weight of a body is less on the moon than its weight on earth. The weight of a body is less on the moon than its weight on earth because the moon has less mass than earth. Due to this, moon exerts a lesser force of attraction on objects. The moon has no atmosphere. The moon has no atmosphere because the magnetic field is too weak and is not able to keep molecules of gas combined together. The value of acceleration due to gravity is greater at the poles than at the equator. The value of acceleration due to gravity is greater at the poles than at the equator because the poles are more closer to the center of Earth. The moon plays a more important role than the sun in causing tides in ocean. The moon plays an important role than the sun in causing tides in the ocean because the sun is 390 times farther from the earth than moon. Tides occur in oceans but not in lakes. Tides occurs in oceans but not in lakes because lakes don't have enough area to significantly move due to gravity. Thank you. This was-
Okay, thank you very much. Okay, so who presented this one? Who presented? Sashank Lamsal. I think this is PDF. Is it PDF? PDF or what is it? Why PDF? Babu? Sorry? Okay. Here are something. Look at here. Newton's law of gravitation is known as universal law. Why? Because this law is applicable throughout the universe, whether micro objects or macro or massive objects, whether bigger objects or smaller objects. Hey. Next one is question number 2. What is given here? Read.
Decrease with an increase in distance from the earth's surface.
Yes. So what is given here? Suppose this is Earth. What is this? Earth. And one body is here. But if the body is taken to this side, then distance increases or decreases. So what is the relation between g and height? That is r plus h whole square. As the altitude increases, acceleration due to gravity decreases. As the body is taken to some altitude, then the value of acceleration due to gravity decreases. When value of acceleration due to gravity decreases, then weight also decreases because weight is directly proportional to acceleration due to gravity. Here we have to mention two things. As the altitude increases, the value of acceleration due to gravity decreases. And when gravity value of acceleration due to gravity decreases, weight of the body also decreases. So on the surface of the earth, the value of g is 9.8 meter per second square. But when you go in upper height, then it may be 9.7 meter per second square, or 9.4 meter per second square, or 3.4 meter per second square, etc. Oh, good. So, what is the height of Mount Everest? 8,850. 48.86, right? 8848.86 meters. If the stone is taken at the top of Mount Everest, then altitude increases. Then what is the value of G there? G at that particular place is 9.77 meter per second square. Means weight also decreases. The value of acceleration due to gravity is more at the bottom of the hill and less at the top of the hill because of altitude. Acceleration due to gravity and altitude are inversely proportional to each other. Okay. Question number 3. What does it say? The weight of stone is less at the top of mountain than it is at bottom. Because what is the relation? G is inversely proportional to altitude. You have to write like this, okay? G is inversely proportional to altitude. So at the top of the mountain, the value of G is more or less? Less. Then weight also will be less. Okay. What is question number 4 say? Weight of a body is less on the moon than its weight on the earth. You know, what is the value of G on moon?
1.9.
G on moon is 1.67 meter per second square. Acceleration due to gravity on moon is how much?
1.67
Meter per second square. Acceleration due to gravity on earth is how much? 9.8 meter per second square. It shows that the value of acceleration due to gravity of moon is 1/6 of earth. 6 times less. 6 times less. If so, automatically weight also decreases. As the value of acceleration due to gravity decreases, weight of the body also decreases. Is it okay? Now, what is the next one? The moon has no atmosphere. Why moon has no atmosphere? Because the magnetic field is too weak. It means its pulling capacity is very less. It does not pull the substances very easily because value of G is very less means pulling power is less. That's why it cannot keep the molecules of gas together. So no existence of atmosphere. Okay. What is the next number? The value of G is greater at the poles than at the equator. This one we have discussed yesterday also. Suppose this is Earth, and if I write here RP, what do you mean RP? It means polar radius. And what is this? RE means equatorial radius. What do you think? RE is greater than RP. Equatorial radius is longer than polar radius. The length of this radius is, equatorial radius is more than polar radius. And when the radius increases, the value of G decreases. Right? So here what to mention there? Polar radius is shorter than equatorial radius, and G is inversely proportional to radius. That's why the value of G is greater at poles than the equator. Okay. Next question is question number 7, right? What is question here? The moon plays a more important role than the sun in causing tides in ocean. Do you know what I mean by tides? You know, Earth's surface is covered with 3/4 of water. Right? No, water is present 3/4, and 1/4 is presence of land. Right? So there are big oceans here. Are here big oceans or not? And what is this?
Moon.
Moon. And what is this?
Sun.
Sun. In between any two bodies, there is mutual force of attraction. What is that force of attraction called?
Gravity.
Force of gravitation or gravitational force. So moon and earth, do they attract each other?
Yes.
Sun and earth, do they attract each other?
Yes.
Which one is closer and which one is far away?
Moon.
Moon is much more closer. That's why its force can be experienced more in comparison to sun, because sun is very far away. By the way, how far is sun and how far is moon from the earth? It is near about 15 crore kilometer far away. How much?
15
15 crore kilometers. It is near about 3.86 lakh kilometer far away. Or let's say near about 4 lakhs kilometer. Near about, it is 4 lakhs kilometer far away. This one is how much far away? 15 crore. So nearer object can cause more force of attraction or far away object?
Yeah.
Nearer. That's why the force of attraction of moon is comparatively more. And tides means, okay, what is tides? So due to mutual force of attraction, this water present in sea and ocean rises. It rises. That rising, no, not wave. It goes completely up and down. It may go up to 12-meter height. How much height? Height, 12-meter height. Okay? Maximum. Otherwise, that wave is different. Wave, just water is moving. But here, due to mutual force of gravitation of moon, water level just rises directly upward and falls down. That is called tide. When the water level goes up, that is called high tide. When water level falls down, what is called low tide. High tide and low tide. So, which force of attraction will be more? Moon's. That's why it affects more, right? Now, next question. Tides occur in oceans but not in lakes. Ocean is very big or very small? Very big. There is more amount of water. In lake there is less amount of water. That's why force of attraction is exerted more on oceanic water, less on lakes water, because area is only less, no? So that water level cannot rise up. Thank you. Finish. Okay, give him a big round of applause. Okay, now let me welcome on this, because she was absent yesterday. Sarniya, are you ready? Yes. Is this the one? She also, no, she made this one. Please. And it's working? Yes.
Namaskar and good afternoon to everyone. As you all know, it's me Sarniya Bumrel. Today I am here to discuss long question answers of lesson 7. Not this one.
Not this one?
Not this one. The first question is, the weight of a body decreases when it is taken to the top of a hill. Explain with reasoning. The weight of a body decreases when it is taken to the top of a hill due to the reduction in gravitational force exerted by the earth. Weight is the force of gravity acting on an object, calculated as the product of the object's mass and the acceleration due to gravity at higher altitudes, such as the top of a hill or a mountain. The distance from the certain of the earth increases since gravitational force decreases with the square of the distance from the earth's center. This means that as you move higher up, the gravitational uh, pull becomes more weaker. Consequently, the weight of the body, which depends on this gravitational pull, decreases. The phenomenon illustrates the inverse relationship between gravitational force and distance from the Earth center. The next question is, when an apple falls towards the earth does not actually come up to meet the apple. Is it true? If yes, why is the earth motion not noticeable? Yes, it is true that when an apple falls towards the earth also moves slightly towards the apple, but this motion is not noticeable. This is due to the difference in their masses. The apple and the earth exert equal gravitational force on each other, but the earth is so massive compared to that its movement is extremely small. According to Newton's third law of motion, for every action there is an equal and opposite reaction. So while the apple falls towards the earth is pulled very slightly towards the apple. However, because the earth's mass is so large, the distance it moves is incredibly tiny, so small that we can't see or feel it. This is why it appears that only the apple is moving. So, with the help of an experiment that the acceleration of a freely falling body does not depend on the mass of of that body. For the experiment, we need materials like two different objects with significantly different masses. For example, a feather and a small ball of clay. A vertical space like a staircase or a platform, stopwatch or timer. The steps of experiment are: step 1, stand at the top of the staircase or platform with both objects in hand. Step 2, ask yourself or students what they expect wi- will happen when both objects are dropped simultaneously. Many might think the heavier object will fall faster. Uh, Simultaneously drop both objects from same height and start the timer. As soon as you release them, observe and record. Observe which object reaches the ground first and record the time it takes. Compare results. Compare the times
What you
recorded
say?
for both objects. You will find that both objects hit the ground at nearly the same time, despite their different masses for each other to fall. Explanation: according to Galileo's principle of falling bodies, all objects fall towards the earth with the same acceleration due to gravity, regardless of their mass. Assuming negligible air resistance, the slight difference in the time recorded might be due to air resistance affecting the feather more than the ball of clay, but the trend should still show that both objects accelerate at the same rate. This experiment helps to demonstrate that the acceleration of a freely falling body, approximately 9.8 meter per second square, on Earth's surface is independent of the mass of the object. The next question is, what is the effect of gravity on a falling object? Write the conclusion obtained from the coin and feather experiment. The effect of gravity on a falling object is described by Newton's law of motion, law of universal gravitation, and the law of motion. When an object falls, gravity causes it to accelerate towards the earth. The acceleration due to gravity near the Earth's surface is approximately 9.8 meter per second square. Regarding the conclusion from the coin and the feather experiment, often demonstrated in vacuum conditions to eliminate air resistance, it illustrates that in the absence of air resistance, all objects fall at the same rate regardless of their mass. This conclusion supports Galileo's findings showing that the acceleration due to gravity acts equally all the objects regardless of their mass, leading to them falling at the same rate in a vacuum. The last question is, under what condition does a body experience weightlessness? When a body is in free fall or falling free towards a celestial body like Earth without any other forces counteracting gravity. This happens because both the body and its surrounding are accelerating towards the earth at the same rate, making it feel like there is no gravitational force acting on the body. Then a body experiences weightlessness. Thank you.
Thank you very much. Give her a big round of applause. Yes. So, these were the long questions, and we have done remaining give reason questions. Already done? Already completed?
Not explained.
Not now explained. Oh, have you prepared? So he will prepare that give reasons also. I think that is left. So long questions. Who has studied yesterday? Some long questions were done by whom? Pujana. She has done some long questions, and some long questions are already solved by um, this girl. Her name is Sarniya Bumrel. Actually, it was the turn to do yesterday, but yesterday there was quite problem as well, right? So the electricity was not helping us, but today is fine, very good. What is given here? The weight of a body decreases when it is taken to the top of a hill. Why? When it is taken to top of a hill, acceleration due to gravity decreases and weight also decreases. In that we have to remember. As the altitude increases, the value of acceleration due to gravity decreases because a altitude is inversely proportional to acceleration due to gravity. Right? And what is second one? When an apple falls towards the earth does not actually come up to meet the apple. It is true. If yes, why is the earth motion not? Okay, you have to remember here. Here is earth. Why is what is here? Apple. When apple falls towards the earth, then both of the bodies move. Apple also moves, earth also moves. But whose motion can be noticed?
Apple.
Apples, because its mass is very less. It travels long distance, but earth is massive body. So it doesn't travel long distance, that's why we cannot notice it. Right? One thing remember, when apple falls towards the earth, then its speed is how much? 9.8 meter per second. That is acceleration, right? But the acceleration of what to say? Earth is it may be 0.000000738 meter per second square. Then it cannot be noticed. Though it travels some distance, but not noticeable due to massive mass. Now next one is, so with the help of experiment that the acceleration of a freely falling body does not depend on the mass of that body. So this one you can do. You can write the experiment of coin and feather experiment. Which one? So coin and feather experiment. Would you remember what to do? You have to take one vessel and keep there two things. What is that? Coin and feather. At first, the experiment must be done in presence of air. Second one, in absence of air, in vacuum. In presence of air, which falls faster? Coin, and with feather falls slower. But when air is pumped out, then both of them fall together. That is the thing. Hey, so this is the conclusion. This is the conclusion of coin and feather experiment. What is that? Acceleration of a freely falling body does not depend on the mass of that body. Okay. So she has applied lots of effort. Actually, why did I give like this work? So that it will be easy for you whenever you go in class 11 and 12, and you can present yourself. If the teacher says, "Is there anybody to present?" You may raise your hand. Yes, sir, I can do. Then when you get praise from others, and you like to do more and more work. But nowadays, I know some of them they don't like also. But Mr. Neumann doesn't like. For lazy students, I will give double work. In class 9, two students were absent today. I've already found them. Students, your punishment is double. They have to present 7 slides. Now, how many slides they have to make? 14 and present. It's like I could give 1 2 slabs also tomorrow, but that's not the solution. What must be done? Under what condition does the body experience weightlessness? So, if a body is falling freely without air resistance, then a body experiences weightlessness. There are some conditions to experience weightlessness. Where can it be experienced? Number one, during free fall. Number second, in space. In space also free fall can be experienced. I mean, when you go up, the value of small g increases or decreases? It decreases, right? And there is one reason. Beyond that reason, the earth cannot pull that body. Then will there be weightlessness or not?
Yes.
So that is the thing. And at the center of the earth also there is weightlessness. And in elevator, do you know elevator? Lift. Inside the lift also, what can be experienced? Weightlessness. Okay, weightlessness. Thank you very much, Miss Sarniya. Now let's welcome on the stage our next presenter, Master Simresh Maharjan. So clapping also their kind of technique. What is it? A pat pat put.
I'm going to explain about the green result
Children, learn everybody.
force and
Motion. Sound of this gift. That's great. Well, laughing. See,
it's not coming.
so,
My animation is not coming.
not coming.
Yeah.
It's coming. It's coming. Wow.
Yeah.
Okay. From I number. Okay, listen.
So first question: it is difficult to lift a large stone on the surface of the earth, but it is easy to lift small one. Answer: large stones are heavier because they have more mass, so they require more effort to lift compared to small stones, which are lighter. This is due to gravitational force exerted by the earth, which pulls object towards the center. Smaller stones have less mass and therefore less weight, making them easier to lift. The mass of the Jupiter is 319 times more than the Earth, but its accelerated due to gravity is only 2.5 more than Earth's. So answer is because the radius of the Jupiter is more as its mass. We know that gravity is inversely proportional to the square of the distance. Okay, number the weight of the body will be 0 during free fall because during free fall the feeling of weightlessness arises because all the objects are accelerating together with the gravity. So L number, a paratrooper can land safely by jumping out of a flying airplane. Answer: because the parachute covers more area, because of which it experiences more air resistance, so it falls slowly and have a safe landing. M number, when a coin and a feather are dropped from the roof of a building, the coin falls faster than the feather because due to air resistance or friction by air for the feather. And number, air resistance is both advantageous and disadvantageous because air resistance can be harnessed for beneficial purposes like braking, cooling, and sport performance. It also presents challenges such as energy consumption, speed limitations, structural consideration in various applications. But if the earth is compressed to the size of the moon, its g increases. Answer: because gravitational acceleration is inversely proportional to the square of the radius. With smaller radius, the acceleration due to gravity on the earth becomes stronger. P number, it is not safe to use a parachute on the moon. Answer: because the moon contains no atmosphere and the parachute rely on resistance to slow down descent, but the moon atmosphere is extremely thin, making parachute ineffective for slowing or controlling descent.
What a lovely.
So Q number is a person feel weightless in an artificial satellite, but not on the surface of the moon, even though it is a satellite, because both the satellite occupies are constantly feel all around, cancelling out the feeling of weight due to gravitational acceleration on the moon's surface. Despite being a natural satellite, Its weaker gravitational field exerts enough force to give a noticeable sense of weight, about the one-third of what is felt on the Earth. Thank you.
Wow. Very good. Yes, yes, yes. That's the thing. Actually, you know, teachers are just like the person who has to cross the river. Cross the river, no? Because they are the person having a boat. They take the then from one bank to another bank. And students are like those people who cross the river and go somewhere else. Right? It's a matter of interest. How lovely slide he has made. He has kept sound also. And those words also were moving very lovely. So it takes a little bit time, but it becomes attractive one. So please do the things differently. It is beneficial for you. Okay, email also is given. Look at his email. Simresh m @gmail.com. Wow, what a lovely thing is there. Wow, wow, wow. Very good. See, yes. So I think horror movie. See, this is not- please read the question. What does the question say? Hello. I said to read one.
Because if you are large stone on the surface of earth, but it is easy to lift small one.
Large stone means it has got more weight. Small, more weight means more mass, more weight. Less stone means less mass, less weight. So for which stone we have to apply more force? For large one, that's why. For large, we have to apply more force. That's why it's difficult. For small, we have to apply less force. That's why it's easy. What is the next question?
Mass of the Jupiter 319 times more than the Earth, but its acceleration due to gravity is
Only 2.5 times more. Why? Because its radius is also how many times more? 11 times more. Radius is how many times more? If the radius is longer, then acceleration due to gravity decreases. Or not? Yes, that's right. Even though mass is 300 times more, radius is also how many times more? 11 times. That's why the acceleration due to gravity is 2.5 times more only. What is next number? Weight of a body will be zero during free fall. Why?
because during the free fall,
Actually, when a body is falling freely, hello, when a body is falling freely, is there air resistance?
no sir.
No air resistance. Then the difference between acceleration due to gravity and acceleration of body is zero.
Yes.
How much? Remember here, during free fall, the acceleration due to gravity and acceleration of the body is how much? Equal. Equal. So when do we find their difference? How much it will be? Zero. That's why the weight will be also zero. Endurance. What next one is question here? A paratrooper can land safely by jumping out of a flying aeroplane on Earth, right? Paratrooper means having the parachute. When he just jump down using parachute, then what will happen? Acceleration will increase or decrease? Decrease tremendously. That's why there is safe landing. But if same thing, same experiment is done on Earth, on Moon, is possible?
No.
Because the parachute doesn't open
Yes.
and it falls very fast, right? What is the next question here?
When an failure or drop from the roof of a building, the queen first fall faster than the feather.
Feather. Why? Or coin, less air resistance applied. Or feather, more. Because mass of a coin is more, mass of feather is less. Next question.
Your resistance.
Air resistance is both advantageous as well as why?
Because it can be
See, because of air resistance, what will happen? Those bodies which fall on the earth surface, they just burn completely. Yes or no? And they just prevent us from great harm. If those big stones fall on us, then what will happen? They will be DP, Dhuja Pati. If that small hail falls on our head, then it may break us. Remember, because when small body falls from top, means long distance, it has got more acceleration and causes more harm. So that is the benefit also. But what is next one here? Air resistance can be harnessed for beneficial purpose like braking, cooling, and sport performance. It also presents challenges such as energy consumption, speed limitation, and what is this? Structural consideration in various applications is given here. Uh, what is given here? Size of the moon. The value of G increases or decreases? Increases. When we squeeze, isn't it? When we squeeze the earth to the size of moon, then what will happen? Suppose this is no. This is the size of earth, this is the size of moon. So radius is here, right? So if this earth is squeezed to moon, then what will happen?
So radius will decrease.
Radius will decrease.
Yes.
When radius decreases,
Gravity will increase.
gravity will increase because gravity is inversely proportional to
Radius.
radius. That's right. You have to remember those things. Okay, now next one is what next question?
A person feel a weightlessness in an artificial satellite but not on the surface of the moon even it is a satellite.
Actually, artificial satellite. Artificial satellite is kept in such place that is called geostationary orbit. What is that? So geostationary orbit means that is one reason near about let's say 4,000 kilometer up from here, and that body revolves around it, and it cannot escape from there also. It cannot come to us also. But moon is how much far away? Near about actually 3,86,000 kilometer, but let's say 4 lakh kilometer. It has got some gravity on it.
Yes.
Moon has its own gravity.
Yes.
That's why we don't feel weightlessness. Artificial satellite does not have its own gravity. That's why we feel weightlessness. Okay. Thank you very much. So these were the presentations of our students whom the work was given. All right, the remaining presentation will be done next day. So children, it's the time to complete these all work. Start right now. Right?